Beneath the serene landscape of Geneva, Switzerland, far below the surface where the Swiss Alps cast their imposing shadows, lies a marvel of human ingenuity, a creation of unparalleled ambition that pushes the boundaries of scientific understanding. It is a place where the very fabric of the universe is probed, where the fundamental forces that govern existence are unraveled, and where humanity's insatiable curiosity may lead us to new heights of knowledge or to the precipice of unforeseen consequences. This is the Large Hadron Collider, LHC, the world's most powerful particle accelerator, a machine of staggering complexity and power. Within its subterranean depths, at the forefront of human achievement, the LHC allows scientists to peer into the smallest constituents of matter, leading to discoveries that have reshaped our understanding of the universe. But as we delve deeper into the mysteries of the cosmos, are we also courting disaster? Renowned physicist Brian Cox, a former CERN researcher, made an interesting announcement that shock waves have sent to the scientific community. He pointed to profound and disturbing developments taking place at CERN, the implications of which are beyond our current understanding. Can the search for knowledge lead us unwittingly down the road to disaster? Before considering the implications of Cox's claim, it is important to understand what the LHC is, how it works and how many problems it can cause. The Large Hadron Collider, operated by the European Organization for Nuclear Research or CERN, is an unparalleled scientific instrument. This colossal machine, a 17-mile ring of superconducting magnets buried deep underground, is the pinnacle of human achievement in particle physics. It accelerates subatomic particles to speeds approaching the speed of light and smashes them together with unimaginable energy, recreating conditions that existed mere fractions of a second after the Big Bang, the event that birthed the universe. The LHC has already led to groundbreaking discoveries, including the elusive Higgs boson, often referred to as the God particle, which is fundamental to our understanding of why particles have mass. Yet, as the LHC continues to probe deeper into the subatomic world, the potential dangers it might unlock cannot be ignored. Recently, Brian Cox emphasized the extraordinary capabilities of the LHC, not just in unlocking the secrets of the Higgs boson but also in potentially creating new, unknown phenomena, including miniature black holes or other exotic states of matter. The LHC's ability to model the formation of the universe is not just a theoretical goal, it is a reality. But with that power comes great responsibility, and if something goes wrong, the consequences are dire. Founded in 1954, CERN is one of the most prestigious scientific organizations in the world, with 23 member countries and an extensive network of collaborating researchers. At the heart of CERN's research efforts is the Large Hadron Collider, a technological marvel that represents decades of scientific progress and international collaboration. The LHC is a huge machine hidden underground near Geneva, where it is shielded from the world's radiation and environmental hazards. The construction of the LHC is a testament to human innovation and ambition, a 27 kilometers long array of magnets, advanced heating systems and a network of particle detectors. These observatories, Atlas, CMS, ALICE and LHCb, are located at key points around the ring, where they analyze the results of the energetic collision between protons. These collisions produce temperatures millions of times hotter than the Sun's core, allowing scientists to study the conditions that existed in the early universe. The LHC's operating magnets are critical to its operation. These magnets guide the protons along their paths, making sure they collide in the right places where the detectors are. To work, these magnets must be cooled to temperatures colder than space, 1.9 degrees above absolute zero. This extreme cold is necessary to maintain the superconducting nature of the magnets, which allows them to generate strong magnetic fields that guide protons. The self-heating system is a technological marvel that can maintain this cold temperature throughout the 27 kilometers long. The design of the LHC is a delicate balance between high power and precision engineering, with each component working optimally to achieve the desired collisions. The Large Hadron Collider is no ordinary car. It is a window into the nature of reality. By accelerating protons to nearly the speed of light and colliding with each other, the LHC recreates the conditions that occurred shortly after the Big Bang. These collisions produce a burst of energy, creating a shower of subatomic particles that scientists can learn to understand the fundamental forces that govern the universe. The LHC's most famous discovery to date is the Higgs boson, a particle that plays an important role in the standard model of particle physics. The Higgs boson is responsible for imparting mass to other particles, and its discovery in 2012 was a major achievement in physics, but the capabilities of the LHC extend beyond the discovery of the Higgs boson. The collider will also be used to study other fundamental particles, such as quarks and gluons, and to explore the mysteries of dark matter, matter that makes up a large part of the universe but remains largely unknown. The known. The LHC allows scientists to observe the interactions between these particles and test the limits of the standard model. By recreating the universe's past, the LHC provides a unique opportunity to study the forces that shape the universe and discover new phenomena that could change our understanding of reality. Although the Large Hadron Collider represents the highest level of human achievement in science and engineering, it also raises ethical questions and concerns. What are the dangers of exploring the unknown? Can our pursuit of knowledge inadvertently produce powers beyond our control? These questions are not just thoughts. The LHC works at the forefront of scientific research, and there is always the risk of unexpected results. One of the most feared around, the case of Anatoly Bugorsky, a Russian physicist who was injured in a particle accelerator accident in 1978, serves as a stark reminder of the potential dangers. Bugorsky was working at the Institute of High-Energy Physics in Protvino, Russia, when he accidentally stuck his head into the path of a proton beam. The beam passed through his skull, causing severe injuries, but Bugorsky survived and continued his work. This incident underscores the enormous power and potential dangers of particle accelerators like the LHC. Understanding how the Large Hadron Collider can create a black hole requires an understanding of particle accelerators. When protons collide at nearly the speed of light, they release enough energy that they can trigger the formation of spacetime. Imagine a long trampoline with something heavy lying on it. The blade will bend, and if there is too much stress, it will cause a hole. This comparison helps to show how the LHC can create a gravitational anomaly, a region of space where the gravitational force is strong enough to create a black hole. The idea of creating black holes in a laboratory is not new, but it is still the subject of debate in the scientific community. Some physicists argue that the LHC could create a small black hole that will rapidly disappear due to a process called Hawking radiation. Named after physicist Stephen Hawking, this phenomenon suggests that black holes can emit radiation that loses mass over time, eventually disappearing altogether. However, the possibility of creating a short-lived black hole raises serious concerns about the risks posed by LHC experiments. Stephen Hawking himself has warned of the dangers of extreme physics experiments. In his writings, Hawking suggested that the Higgs boson could slow down to high energy levels, possibly leading to the catastrophic collapse of the vacuum, a cosmic event that could destroy the universe. Although this scenario is highly fictional, it illustrates the problems associated with pushing the boundaries of scientific research. The LHC is working at levels of energy never seen before in human history, and the potential for unexpected results cannot be ruled out. The concept of a vacuum is a theoretical idea that has been discussed by several famous physicists, including Stephen Hawking and the famous astronomer Sir Martin Rees. The instability of the vacuum is associated with a hypothetical situation where a high-energy event, such as a particle collision at the LHC, changes the phase of spacetime. This phase shift will spread throughout the universe, changing the basic properties of matter and energy, leading to a catastrophic event. In his book Our Final Hour, Sir Martin Rees explored the potential dangers of nuclear fusion experiments and other high-energy physics research, including the potential instability of the vacuum. Rees argued that while these scenarios are highly speculative, they cannot be completely ruled out. The consequences of such an event are very serious, although the probability of it happening is very small and should be considered carefully. The stakes are very high and the margin for error is the size of the razor blade. CERN and the international scientific community have been working hard to prevent problems with the LHC experiments. Safety measures and testing procedures are in place to reduce the risk of accidents. However, the lack of scientific research, especially in the fields of education, means that some of the problems cannot be completely eliminated. The pursuit of knowledge is always fraught with danger, but it is this effort to push the boundaries of what we know that has led to great human achievements. Ethical dilemmas for high-energy physics. As we examine the potential dangers of the Large Hadron Collider, it is important to consider the ethical implications of high-energy physics research. The LHC is a testament to humanity's continued pursuit of understanding the fundamental laws of the universe. But beneath the LHC's impressive exterior is a field of research full of risks and ethical considerations. The experiments conducted at CERN involve forces and energies that are not understood by most lay people, and the results of these experiments are not always clear. The ethical dilemmas facing the LHC and similar experiments revolve around potential risks for humans and the environment. Should we continue to push the boundaries of scientific research, even if it means putting ourselves in danger? What is the responsibility of scientists to ensure that their work does not inadvertently lead to disaster? These questions are not easy to answer, but they are worth thinking about when we go deeper into the unknown. One of the most important ethical concerns is the risk of creating situations that have unintended consequences for the world. The creation of tiny black holes, for example, raises the question of whether properly conducted experiments could disrupt the Earth. Although CERN scientists have told the public that the risk is low, the fact that it turns out to be a risk is enough to give you pause. The possibility of negative events, although impossible, cannot be ignored when conducting research at the edge of the scientific world. Despite the potential problems, the Large Hadron Collider represents the future of scientific research. Its unique capabilities and potential for breakthrough discoveries will make it a valuable tool in the quest to understand the fundamental nature of the universe. The LHC allows scientists to reconstruct the early universe, sometimes after the Big Bang, and provides a unique opportunity to study the Higgs boson and other fundamental particles. This research has great implications for our understanding of the world, and it will lead to a new theory that will change our understanding of the world. The LHC is not just a scientific instrument. It is also a symbol of global cooperation and human achievement. The project involves thousands of scientists from around the world working together to unlock the mysteries of the universe. The discoveries made at the LHC have the potential to change the course of human history, leading to new technology and a deeper understanding of the universe. But as we continue to push the boundaries of knowledge, it is important to do so with an understanding of the consequences and a commitment to ethical research. The LHC's ability to investigate the structure of reality will be central to physics and cosmology. The main goal is to study the basic particles that make up the universe, but the results of this research go beyond the scientific world. LHC. One of the most significant areas of research at the LHC is the study of dark matter. Dark matter is a mysterious substance that makes up about 27% of the universe, yet it remains largely unknown. Unlike ordinary matter, dark matter does not interact with light, making it invisible to traditional telescopes. However, its presence can be inferred from its gravitational effects on visible matter, such as galaxies and clusters of galaxies. The LHC offers a unique opportunity to study dark matter by recreating the conditions of the early universe. By smashing protons into each other at high speeds, scientists hope to produce dark matter particles that can be detected and studied. This research could provide important insights into the nature of dark matter and its role in the universe. Understanding dark matter is important to our understanding of the universe, as it plays a key role in the formation and evolution of galaxies. In addition to dark matter, the LHC also allows researchers to study other fundamental particles such as neutrinos and quarks. These particles are the building blocks of matter, and understanding their behavior is essential to our understanding of the universe. The LHC's ability to probe the subatomic world at unprecedented energy levels will make it an invaluable tool in the quest to unravel the universe's mysteries. As we look to the future of scientific research, the Large Hadron Collider will undoubtedly play an important role. His ability to reconstruct the past and study the fundamental particles is an important tool for advancing our understanding of the universe. The LHC has already produced groundbreaking discoveries such as the Higgs boson, and the potential for future discoveries is huge. However, the legacy of the LHC is undoubtedly controversial. The potential risks associated with high-energy physics research have raised ethical questions and questions that will continue to be debated for years to come. The risk of creating situations that could cause harm to the world cannot be ignored, making it even more important for researchers to conduct safe and ethical research. The LHC is a symbol of human understanding and the pursuit of knowledge. Representing the cutting edge of scientific research, the boundaries of our understanding are constantly changing. But as we continue to explore the unknown, we need to be fully aware of the risks that arise and committed to the ethical considerations that arise from these studies. The Large Hadron Collider is no ordinary scientific instrument. It is also a symbol of international cooperation. The project involves thousands of scientists from around the world working together to unlock the mysteries of the universe. This collaboration is essential to the success of the LHC, as it allows scientists to share resources, expertise, and knowledge. CERN, the organization that runs the LHC, was founded in 1954 as the European Organization for Nuclear Research. Since its inception, CERN has grown to include 23 member countries and a large network of collaborating researchers. This international collaboration is essential to the success of the LHC, as it allows researchers to pool their resources and work together to pursue a single project. The LHC is an example of what can be achieved when scientists from different countries come together to pursue a common goal. The discoveries made at the LHC have the potential to change the course of human history, and these discoveries are the result of the collaboration of scientists around the world. This international collaboration is a reminder of the importance of working together to achieve great achievements. Looking to the future, the Large Hadron Collider will play an important role in scientific research. His ability to reconstruct the past and study the fundamental particles is an important tool for advancing our understanding of the universe. The LHC has already produced groundbreaking discoveries such as the Higgs boson, and the potential for future discoveries is huge. The LHC is currently being upgraded to increase its power level and improve its performance. This upgrade allows scientists to dive deeper into the subatomic world and explore new areas of research. The LHC has a bright future and will undoubtedly continue to be an important tool in the quest to understand the universe.